Okay, so we're going to be factoring polynomials today. So the very first thing that you always check for whenever you're factoring is GCF, which means greatest common factor. If your first term is negative, you're going to always factor out a -1. If they have something other than 1 in common, then you would factor out a negative whatever that number is. Okay, so we always want that first term to be positive. Okay, so looking at number 1, 3x squared plus 6x, we're wanting to find the GCF, which is your greatest term that will go into both of those. So that would be a 3. And then you have an x squared and a 6, an x squared and an x. And if they both have that variable in common, it's always that smallest variable that you will factor out, so x. So we write our GCF, and then we're opening up parentheses. To determine what's left, we're going to divide each one of our original terms by the GCF. So you should end up with x, when you divide that, plus 2. If you distribute 3x to x plus 2, you should end up getting 3x squared plus 6x. So that would be our answer there. Okay? So when you're factoring, you're just rewriting it a different way. It should always be equal. Okay, let's look at example 2. So notice the first term is negative, so I'm going to go ahead and put a negative here because we always want that first term to be positive. And we have a negative 6x cubed plus minus 4x squared plus 8. The GCF of all three of these would be a 2. And then notice that last term does not have an x, so we can't take an x out if they all don't have it in common. So the only GCF we would have is a -2. So I would divide each one by -2. So you would have left 3x cubed plus 2x squared minus 4. Okay, again, you can distribute that -2 to all three of those terms, and then it should give you back your original trinomial that you had. So you're always checking for GCF first when you're factoring. Okay, let's look at some special patterns that we will be seeing. These special patterns on these examples here are 2 terms. So anytime you have 2 terms, you first check for your GCF, then you're either checking for difference of squares and sum and difference of cubes. Those are the 2 things that you will be checking for. Okay? All right, a perfect square. We have a perfect square number is a number multiplied by itself. That answer is considered a perfect square number. Okay, so for example, 1 squared is 1, so 1's a perfect square number. 2 squared is 4, 4 is a perfect square. 3 squared is 9, and then etc. Okay? All right, so cubes, perfect cubes. If you notice on your notes that they're written right here. So 1 cubed is 1, 2 cubed is 8, 3 cubed is 27. So 1, 8, 27, 64, and so on. Those are perfect cube numbers. Okay, so let's look at number 3. So first we check for a GCF. They do not have anything in common. Okay, so we're either checking for difference of squares or sum and difference of cubes. So we know we don't need to check for cubes because notice that we have an x squared term. So we need to check for squares. Notice that x squared, that is a perfect square because we can do x times x to give us x squared. And then notice 9 is a perfect square. When you have perfect squares, you always need to check and make sure that it's difference. So notice we are subtracting there, so that would be difference of squares. When you're factoring difference of squares, you should have 2 binomials for your factors. To get those factors, you're going to take the square root of the first term, so square root of x squared is x. That will be my first term of each factor, and then the square root of 9 is 3. Notice on your formula that it's a plus b, a minus b, so it should be x plus 3, x minus 3. To check that, we would be doing what we did yesterday. Multiplying those binomials together, you should end up getting x squared minus 9. Because remember, when you add to get that middle term, and 3 and a -3 would give you 0. So if you multiply those two together, it should give you x squared minus 9. Okay, looking at example 4. We have x cubed plus 125. Notice they don't have anything in common. We have an x cubed, so we need to check for either sum or difference of cubes. So x cubed is a perfect cube. If you look over here at your chart, 125 is also a perfect cube. Okay, so this is sum of cubes. So if you look at your formula here, we have 2 terms and then we have 3 terms. Okay, to get your first 2 terms, you're going to take the cube root of x cubed, which is x, and then the cube root of 125, which is 5. Okay. All right, so now we're going to check to see what our sign will be. When we're dealing with cubes, whether it be sum or difference, you're going to use SOAP. Okay, that will help you determine what the signs will be. The first sign will be the same as your original polynomial. So notice that we have a plus here, so this will be a plus. Okay, so we found our first binomial. The next part, we're using this binomial to get this trinomial. So notice on your formula, you have an x squared. So all we're doing is we're going to square this term here, which would give us x squared. And then your second sign will be the opposite. So since we had a plus, the opposite of that would be minus there. Okay. To get your middle term on cubes, you're multiplying x times y. So x times 5 would give you 5x. And then your last term is always positive. The reason is because notice on your formula you're squaring this y term. So when you square 5, you get positive 25. So there's your answer. Okay, let's take a look at number 5. So 2 terms, notice they don't have anything in common, so we're checking for either perfect squares or perfect cubes. Notice that we have x squared terms, so let's check for squares. I keep messing up there. There we go. Okay, so 25 is a perfect square. 49 is also a perfect square. And notice that we are subtracting because it has to be difference of 2 perfect squares. So to factor that, we'll open up 2 sets of parentheses. We'll have a binomial and a binomial. We'll take the square root of 25x squared, which is 5x. The square root of 49y squared is 7y. Remember, one's a plus, one's a minus. You should be able to use FOIL, multiply them together, and it should give you back your original. Okay, so looking at 6, we have 2 terms. They don't have anything in common, so we either need to check for squares or cubes. Notice that we have 2 perfect squares. X squared is perfect, and so is 9. But notice that this is sum. So this would be sum of squares. Notice on our special patterns, it only says difference of squares. Okay, so if you don't have a GCF and it's sum of squares, it's not factorable, which means you will write prime. So not factorable. Okay, so anytime you have sum of squares, you can't do it because there's not any factor times another factor multiplied together that would only give you x squared plus 9, because x plus 3 times x plus 3 would give you x squared plus 6x plus 9. Okay, so you would have that middle term. Okay, let's look at 7. All right, so 2 terms, they don't have anything in common. So we're checking for squares or cubes. Notice we have an x cubed, so we need to check for perfect cubes. So 8, if you look at your little chart, 8 is a perfect square or perfect cube, and 343 is also a perfect cube. Okay, so this is difference of cubes here. So remember on your cubes, if you look at your formula, you're going to have 2 terms, and then you're going to have 3 terms. To get the first 2, you're taking the cube root of 8x cubed, which is 2x. And then remember you use SOAP to find the signs when you're dealing with cubes. Okay, the first sign is the same, so that would be a minus. The cube root of 343 is 7. And then we're using that binomial to find this next trinomial. So I'm going to square that term, which would be 4x squared. We use the opposite sign, so plus. We multiply these two together, which would give me 14x. It really gives you negative 14x, but remember, you're using the opposite sign there, so it has to be plus. And then your last term is always positive because you're squaring negative 7, which is 49. So you should be able to multiply these together, and it should give you back 8x cubed minus 343. Okay. All right, let's look at the back. Those were all 2 terms that we were looking at. Now we're going to look at 3 terms. It says if there are 3 terms and the number in front of x squared is a 1, you're going to factor mentally. When you have 3 terms and the coefficient of x squared is 1, you're going to figure out what will add to the middle number multiply to the outside number, or that last term. Okay, so you want the sum to be 15, you want the product to be 36. If you can't figure out the 2 numbers in your head, write all factors that will multiply to give you 36. Go in order, because when you get to larger numbers later on, you might accidentally skip over 1 and then not be able to find it. So make sure you go in order. So 1 times 36, that will not add to 15. So go to the next number, 2. So 2 times 18, notice those 2 will not add to 15. Go to 3, 3 times 12, and you will be able to add those to give you 15. So when you're writing your factors, you would have x plus 3 and x plus 12. When you multiply them, x squared, you add to get the middle, which would give you 15x, multiply to give you 36. Okay, so looking at 9, always check for GCF first, but notice they don't have one. 3 terms, coefficient of your x squared is a 1, so you want the sum to be that negative, or that middle number, which is negative 9, and you want the product to be 14. So since you're adding to get a negative, multiplying to get a positive, both of them would have to be negative. So that would be negative 2 times a negative 7. So that would be x minus 2, x minus 7. And it doesn't really matter which one you write first. So you could have x minus 7 times x minus 2. That's the same answer. Okay, 10. Doing the same thing. So we want the sum to be 9, product to be negative 22. Since we're adding to get a positive, multiplying to get a negative, only one term is going to be negative. So that would be negative 2 and 11. Again, if you can't figure it out, just start with 1 and keep going until you find it. So we would have x minus 2, x plus 11. Now, if your sum was a negative 9, then you would have to change those negatives. It would be a positive 2 and a negative 11. So make sure the sign does matter. So make sure you put the correct sign with the correct number. Okay, 11, we want the sum to be -5, product to be -14. So that would be, since we're adding to get -5, multiplying to get -14, one term will be negative, and that would be 2 times a -7, because we want to add to -5. So that would be x plus 2, x minus 7. So if the sum was +5, it would be a -2 and a +7. All right, now we're going to look at number 12. This next part, we're going to factor each of the following completely, which means we're going to factor until we can't factor anymore. So remember, the very first thing that we check for is GCF. So on number 12, notice the GCF, the greatest number that would go into all three is a 3. Let me write that somewhere else. Okay, and then notice they don't all have a variable in common, so that would be the GCF. So remember, we're dividing each one by the GCF. So that would give you x squared plus 8x plus 15. Okay, so once we take out the GCF, we're looking to see how many terms we have inside our parentheses. So notice we have 3 terms. So if you look at your blue sheet, 3 terms, you want to figure out what will give you the sum of the middle number, which is 8, the product of your last number, which is 15. So that would be 3 and 5. If you can't figure it out, write them all down. So that would be x plus 3 and x plus 5. Now, we want these to be equal. If we multiply those, we want it to give us back the original. So remember, you always have to include your GCF in your answer, because we want it to equal the original polynomial that we had. Okay, so 13. Notice the first term is negative, so I know I'm already going to take a negative out. The GCF would be 5 and x, because notice they all have that variable in common. If they all have the variable in common, it's always the smallest one that you have that you'll take out. So we're going to divide each one by -5x. So you would have x squared, that would be minus 10x, and that would be plus positive 24. Okay, so we took out the GCF. We're looking to see how many terms we have. We have 3. So we want the sum to be -10, the product to be positive 24. So since you're adding to get a negative, multiplying to get a positive, both of them would have to be negative. So remember to rewrite or bring down your GCF, and that would be x minus 6 and x minus 4. Remember, it doesn't matter the order that you write those. So you could have -5x and then times x minus 4 times x minus 6. Okay, number 4. First thing we check for GCF. Notice the GCF of these two would be 5. And they both don't have an x, so that's the only thing that we could take out. So 125x squared divided by 5 would give you 25x squared. And then 80 divided by 5, you get minus 16. So notice this time after we took out the GCF, we have 2 terms. Remember back from the front, when you have 2 terms, you're checking for either perfect squares or perfect cubes. Notice 25 and 16 are perfect squares, and we are subtracting because you have to also check for that. So this is difference of squares. So bring down your 5, and then I'm going to open up 2 sets of parentheses. Remember, you have a binomial times a binomial whenever you have difference of squares. Okay, so I'm going to take the square root of 25x squared, which is 5x. Square root of 16 is 4. remember you'll add one and subtract the other. If you were to use FOIL and multiply those two together, it would give you back that 25x squared minus 16. And then you could distribute the 5 and give you back the original. Okay, this last one. First thing that we check for, remember, is GCF, and then notice that that first term is negative, so we're going to take that negative out. And then notice they have a 3 in common. And then we have an x cubed and an x squared. Remember I told you if they both have that variable in common, you're always going to take out the smallest one, which is x squared. So they both have 2 x's in common. So when I take that out, dividing each one by negative 3x squared. So you have left x plus 4. Okay, so we took out the GCF. Notice we have 2 terms. And notice that is not difference of 2 perfect squares because we just have an x. That's not a perfect square. Okay, so the answer is not prime because we were able to factor out a GCF. That is factoring also. Okay, so that would just be our answer. So even though the inside part, once you factor out your GCF, doesn't factor, that doesn't mean that it's prime. Okay, so your answer, you just stop there. So that would be the answer there.